Alright, today we're going to be learning about solving systems algebraically. So the students will be able to solve linear quadratic and quadratic systems of equations algebraically. Last class we learned how to solve them graphically. So let's start off by using two linear equations to solve. So we're going to solve by substitution. It means we're going to figure out what one variable is and plug it in for another, or into the other equation. So here we know that y equals 1/3 x plus 4. So we're going to plug that in for the y in our other equation. So x plus 3 times 1/3 x plus 4 equals 6. So now we're going to do some basic algebra. Distribute the 3. Bring down the x. 3 times 1/3 is 1. 3 times 4 is 12. Equals 6. Combine our like terms. Solve for x by subtracting 12. And then divide by 2. X equals -3. Now we can use that to figure out what y equals. Since we want to figure out what y equals, I would use the equation that says y equals. So y equals 1/3 times -3 plus 4. Type that all straight in your calculator, and that comes out to equal 3. So we know our solution is the coordinate -3, 3. Make sure you remember to put your x first and your y second. So let's look at another one. In this system of equations, we don't know what y equals yet or what x equals. It doesn't matter which one. So we need to rearrange one of the equations. Since this x does not have a coefficient with it other than 1, that's the one I'm going to choose to do. So I'm going to add x to both sides, or sorry, add y to both sides to get it positive. And then I'm going to add the 5 to the other side so that the y is by itself. So we end up with y equals 3x plus 5. Now that I know what y equals, I'm going to plug it into the y in the other equation so that I can solve for x. So I get 4x minus 3 times 3x plus 5 equals -5. Distribute the -3. Combine like terms. Now get x by itself. Add 15. Divide by -5. We get that x equals -2. Now we're going to plug that in to the equation that was already written as y equals, this one right here. So y equals 3 times -2 plus 5. 3 times -2 is -6, plus 5 is -1. So our solution is -2, -1. Now, remember from last class and looking at the pictures, we could have anywhere from 0 to 4 solutions for our systems that involve quadratics. So, in our first example, we know that y equals x squared minus x minus 6. So we're going to take that and plug it in for y. So x squared minus x minus 6 minus 2x equals -2. So we're going to combine our like terms. X squared minus 3x minus 6 equals -2. Since we have x squareds and x's, we know we need to either factor, complete the square, or use quadratic formula to solve. 2 out of 3 of those involve making our equation equal 0, so I'm going to go ahead and add the 2 over. X squared minus 3x minus 4 equals 0. Let's see if we can factor this, because that tends to be the least amount of work. What two numbers multiply to give us -4 and add up to -3? That would be x minus 4 and x plus 1 equals 0. So that tells us that x can equal 4 or x can equal -1. Now we need to figure out what y values go along with each of these. Again, we're going to choose the equation that already says y equals, since we're looking for what y equals. So we're going to have 4 squared minus 4 minus 6 and -1 squared minus -1 minus 6. Here we get that y equals 6. Just type it in your calculator just like that. So our solution would be 4, 6. And here we get that y equals -4. So our other solution would be -1, -4. On to our second example. We know that y equals x plus 1, so we're going to take that and plug it in for y. We end up with x squared plus x plus 1 squared equals 25. We need to square this. When we square it, that means x plus 1 times x plus 1. You cannot just square each term. So we're going to multiply this out. We're going to bring down this x squared plus x times x is x squared. X times 1 is x. 1 times x is another x. And 1 times 1 is 1. And it still equals 25. I'm going to combine like terms here. 2x squared plus 2x plus 1 equals 25. Again, since we have x squares and x's, we need to make it equal 0. So 2x squared plus 2x minus 24 equals 0. What do you notice about all of these terms? They're all divisible by 2. So we get x squared plus x minus 12 equals 0. What two numbers could we multiply to get -12 that'll add up to x? That would be +4 and -3. So our factors are x plus 4 and x minus 3 equals 0, which tells us that x equals -4 or x equals 3. Then we're going to go back and use our y equals equation to plug into. So we'd have y equals -4 plus 1, which equals -3. So one solution is -4, -3. Oh, not yet. We also have y equals 3 plus 1, which will give us 4. So our other solution is 3, 4. And those are our two solutions to this system. On to our last two examples. What are the x values for the solutions to the given system? So we don't need to find the full intersection, we just need to find the x values. So since we know what y equals, it equals x squared minus 16, I'm going to go ahead and plug that in for y on the other equation. So x squared minus 16 equals -x squared minus 4x plus 14. I'm going to move all of these to the left because I want to have a positive x squared when I'm finished. So I have 2x squared plus 4x minus 30 equals 0. What do you notice about all your terms? They're all divisible by 2. X squared plus 2x minus 15 equals 0. What two numbers will multiply to negative 15 and add up to 2? That would be positive 5, so x plus 5, and negative 3, so x minus 3 equals 0. So that tells us that x can equal negative 5, or it can equal 3. And since all it's asking for is the x values, we can stop there. Now our final example is something a little different. It wants to know if 2, 4 is a solution to the system of equations. So to be a solution, it must make both equations true. So in our coordinate, the 2 is our x and the 4 is our y. So let's look at the first equation. We'd have 4 equals 2 squared. Well, 2 squared is 4, and 4 is equal to 4. So yes, it worked for the first equation. Then we need to try the second equation. We'd have 2 squared plus 4 minus 2 squared equals 4. 2 squared is 4 plus 4 minus 2 is 2 squared equals 4. 4 plus 2 squared would be 8 equals 4. That is not true. So therefore, 2, 4 is not a solution. It worked for one, which is great, but it didn't work for the second one. So make sure you check both. This also is a way that you can check your answers that you've gotten in the previous examples. Plug in 4 to both equations and see if, plug in 4 for your x and 6 for your y, and see if you get a true statement. Plug in negative 1 for your x and negative 4 for your y's, and see if you get a true statement. That's all for today. See you in class.